Welcome to the remainder of the notes on particle motion. Yesterday we went over one example problem in class, and those notes are on the web. And today we're going to do this example. And so here we have another particle that's moving along the x-axis at the time given by x of t equals t over 1 plus t squared. And this time it specifically says that this is for t values greater than or equal to 0. So our very first question asks us for the velocity. And we all know that velocity is the derivative of our position function, which in this case is named x because this particle is moving along the x-axis. So our output is actually x values. All right, so when I look at this function, I'm thinking quotient rule. It looks like the way to go. So I'll take the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now I'm guessing that I'm going to want this cleaned up so it's useful, so I'm going to go ahead and do that. 1 plus t squared minus 2t squared all over 1 plus t squared. Oops, I forgot my squared up here. There we go. And then we end up with 1 minus t squared all over 1 plus t squared squared. And we can see that our critical numbers for this, if we just look up at the top here, so if I'm looking right up here at the top, that's when it's going to equal 0. And the critical numbers are at 1 and -1, because that would make our function 0. But as it turns out, since t is greater than 0, I never have to consider t equal to -1. So my only critical number I'll have to consider is 1. All right, so let's look at the next question, which asks us, when is the particle moving to the right or the left? And to do this, we're going to want a sign chart for velocity, because when velocity is positive, we move to the right, and when it's negative, we move to the left. This one started at time equal to 0, and my critical number was at 1. So there's my critical number. And I just need to do a sign chart here, and I look at numbers between 0 and 1 if they're placed in this numerator. So 1 minus, say like 1/2 squared, that's going to be positive over positive. So I can see that I'm moving to the right there. But then when I look at numbers greater than 1, when I take 1 minus this really large squared number, I get a negative on top. The bottom, you'll notice, is always positive because it's squared. And so that turns out to be negative. So it is moving to the right from 0 to 1, and it is moving to the left from 1 all the way to infinity. All right, our next question is going to ask us, what is the total distance traveled in the first 3 seconds? So let's just go back to our work on the previous page. The first thing we're concerned with is, did it change direction? And you'll recall down here, it did change direction. It went to the right and then to the left. So I need to consider the time from 0 to 1 separate from the time from 1 to 3. And while I'm here, I'm going to want this position function so I can evaluate it. So we're just going to copy that, and we're going to need that over here. And we'll just paste that equation here so that we have it handy. So in order to find the total distance traveled in those first 3 seconds, I'm going to need to take, first off, what happened from x1 to x0. So I'm going to subtract those. I put absolute value because the distance traveled is always positive. And then I take it from x3 minus x1. And you'll recall that here I was moving to the right, and then for the rest of the time I was moving to the left. Let me just double check that, make sure I have that right. Yes, to the right and then to the left. So I need to calculate those separately. So if I just look at this function here, if I plug in 0, so 0, 0, 0, I can see that I'm going to get 0. So that's that number there. Let's try that again. Now we're going to plug in 1. So if I go over here and I'm plugging in 1, so x of 1, 1 over 1 plus 1 squared, that looks like 1/2. And I've already done 1, so there's the 1/2, and I need to do 3 now. So let's plug in 3. So x of 3, I plug in 3 here and 3 here, and I can see I'm going to get 3/10. 3/10 minus 1/2. All right, so this first subtraction is easy, just 1/2. I'm going to get this out of the way. It's going to get a little crowded here. And then in this second one, we got to do a little work with fractions. So let's see, we've got 3/10 minus 5/10 looks like negative 2/10, which is 1/5. Remember, we were taking the absolute value of all of these. So absolute value, absolute value. So now to get the total distance, so the total distance, we're going to add those up. So our total distance is going to equal 1/2 plus 1/5. Or if we put it in terms of tenths, that's going to be 5 plus 2, or 7/10. So we have now got the total distance traveled by this particle from 0 to 3 seconds. All right, our next slide is going to actually already give us the acceleration. So we didn't have to work through finding this derivative. It's given to us. But we're asked on what intervals is the acceleration positive and negative. And this, of course, is the second derivative. All ready to go. So what we need here is the critical number. So first I look on top and I say, okay, when is that going to equal 0? So I see the 2t and I can see, okay, that's going to equal 0 when t equals 0. And then for t squared minus 3, I might consider t squared minus 3 equals 0, t squared equals 3, and I get two values, plus or minus root 3, but you might recall that t is greater than 0. Therefore, my only other critical number I need to consider is root 3. So for acceleration, I can do a sign chart. Again, it starts at time 0, and the time where it might change is at root 3. All right, so I'm going to go in here and evaluate that. So let's take a different color. Here, for numbers between 0 and root 3, this part's positive. Numbers between 0 and root 3, let's try like 1. 1 squared minus 3, that's negative. And down here, if I put in 1, that's positive. So I can see that this first portion is negative. Now let's take a look at what happens for numbers greater than root 3. And if we have numbers greater than root 3, see, this is positive, this is positive, and that's positive. So there it is positive. So we can answer the question here. The acceleration is positive from root 3 to infinity, and it is negative from 0 to root 3. All right, our last question is asking us if we are speeding up or slowing down when t equals 2. So we have to know something about the velocity at 2 and the acceleration at 2. But we actually only need the sign. Now, if I look at the chart up here, I know that 2 is greater than root 3 because 2 is root 4. So I know that that's sitting right over here somewhere, and it's positive. So I know that a of 2 is greater than 0. And then I'm going to go back a few, probably one slide, nope, 2 slides, and there's my velocity, and oh, there we go. Here's my chart for velocity, and I'm interested in what is happening at 2, and I can see my velocity is negative at 2. So I know that v of 2 is less than 0. Therefore, they have opposite signs, which means I am slowing down. So slowing down because acceleration and velocity have opposite signs when t equals 2. You'll recall, like we talked in class, the forces are working in opposite directions. So velocity is heading in a negative direction, while the acceleration is pushing its force in a positive direction. So they're really working against each other, which is why you're slowing down. All right, so your homework now is to work on the particle motion worksheet, and don't forget the back side. Don't forget to do the free response question on the back side. All right, good luck.